In this lesson, we'll be talking about operations with radical expressions. Let's go ahead and take a look at adding and subtracting first, and then we'll move into multiplication and division. Looking at this first example, we have 3 root 6 plus 2 root 6. The way I want you to imagine a root is kind of like a variable. So I'm just going to kind of write something right above this, and you'll be able to see the similarities between something we've already talked about before and this new concept. Let's pretend that the radical expression is a variable, and we were just adding 3x plus 2x. Do you see how I substituted a variable in for that radical expression? And notice also that the radical expression in this case is the same, which is why I left the variables the same. We know that this would end up equaling 5x. Well, working with radical expressions, it actually works the exact same way. We can kind of say that the last name of the term is the same. So we can add them together. We can add those coefficients together. So in this case, 3 root 6 plus 2 root 6 would give us 5 root 6. And you, of course, do not need to write this down up at the top. That was just kind of showing you an example. Let's go ahead and try this next one. This one, we actually have a little bit of addition and subtraction embedded in the same problem. So what we want to do is we want to first find the radical expressions that are the same. So you can see here that this first term, 3 root 2, has the same radical as positive 2 root 2. So in that case, I can actually add those two together to give me 5 root 2. Notice how the only thing that actually changes is the coefficient in the front. The radical stays exactly the same. Then what we can do is look for any other radicals that are the same. So in this case, you can see we have negative 1 root 5. Don't forget about that imaginary negative 1 there. And then we also have negative 2 root 5. Because they're the same, we can take those coefficients and we can subtract them. So negative 1 minus 2 is going to give us negative 3, and we're going to leave root 5 exactly the same. Now that we've used all of the pieces in the expression, we're done. Okay, now let's go ahead and bump it up just a little bit. We're going to have to do a little bit of work here in simplifying some radicals that we learned in the a previous section. So in this next one, we have 2 root 20 plus 3 root 45. Hopefully you notice that root 20 and root 45 are not simplified. So we actually have to simplify them. So I usually go ahead and identify where the operation is, which is addition. And I like to just draw a little line, kind of separating them from each other, because we're going to actually simplify two separate problems here. Let's go ahead and simplify the first one. So 2 root 20 can be broken down into 2 times root 4 times root 5. And we learned these simplifying techniques in a previous section with simplifying expressions. So feel free to take a glance at that again if you need to. I can simplify this by saying 2 times root 5. Now that everything is broken up, I can go ahead now and combine those coefficients. So 2 times 2 is 4, leaving me with 4 root 5. Now, that's just the left side. Let's go ahead and work with the right side. 3 root 45. I can break that down into 3 times root 9 times root 5. And of course, I can go back and simplify that. 3 times root 5. And then I can simplify that down to 9 root 5. Okay, now that we've simplified the expressions, now we can actually go ahead and add them. We can see that our operation is right up there, and I'm just going to go ahead and carry him down here to the bottom. And now you can see we're kind of going back to that step that we did in the previous two problems, where we have the same radical. We have radical 5. So what we can do is just add those coefficients, and that'll give us 13 root 5. So the difference between this problem and the last two problems is in the last two problems, we didn't have to simplify any of those radicals. But in this problem, we did. We had to take an extra step, simplify them before we added them. Let's go ahead and do another example. This time you can see that this expression has 3 terms in it. So, and you'll also notice that those radicals are not simplified. So the first thing you have to do before you add them is you have to simplify them. So I'm going to go ahead and locate my operations, and I'm just going to go ahead and draw a little line down because I'm just going to separate the 3 problems so I can simplify them. The first one can simplify down into 2 times 9 times root 2. And don't forget about using Desmos to help you find those factors that radical breaks into. And of course, I can simplify that down into 2 times 3 times root 2. And since all 3 of those pieces are fully simplified, I'm going to go ahead and smush it together. 2 times 3 is 6, and it's going to be 6 root 2. Let's go ahead and do the center one, 4 root 12. So that breaks into 4 times root 4 times root 3. I can keep simplifying. 4 times 2 times root 3. Now that everything's simplified, I can go ahead and smush it together. So we have 8 root 3. I've got one more to simplify. So I've got 5 times, I'm going to break it into root 25 and root 3. And that, of course, simplifies into 5 times root 3. Smush it together, 25 root 3. Okay, the only thing I did there was simplify each of those radicals. Now I need to figure out what I can combine. So I'm going to carry down my addition operations. And now it's simply just a problem like the first 2 we did on this slide. We need to figure out what we can add together. And in our case, we can add 8 plus 25, giving us 33 root 3. So the final answer will be 6 root 2 plus 33 root 3. And that's how you add and subtract radical expressions. Okay, now let's go ahead and take a look at multiplication. Multiplication looks a little complex, but once you kind of get started, it actually just turns into an addition or subtraction problem, and you'll see that here. So let's take a look. We have 4 root 5, and we're multiplying it by a quantity, you can see that in parentheses, of root 10 plus 3. That means I need to distribute 4 root 5 into both of those terms. So let's go ahead and just distribute it into that first term of root 10. Remember, using the product rule, you can multiply the numbers underneath the radical symbol, okay? And of course, the numbers that are outside of the radical symbol, you'll want to multiply those together as well. So here we have 4 times, don't forget the invisible 1 here. So 4 times 1 is 4. And then root 5 times root 10 gives us root 50. That's the first piece. Now let's go ahead and multiply the second piece. So 4 root 5 times 3. I have 4 times 3, which is going to give me positive 12. And root 5 is not being multiplied by another root, so I'm just going to leave it as is as root 5. Once you've done the multiplication, now we're just going to use that skill that we just did in the last 2 problems. I'm going to go ahead and split up my problem into 2 separate little problems here. And let's go ahead and simplify. 4 times, I'm going to break this into 25 and 2. So root 25 times root 2. Keep simplifying everything. And that's going to simplify down to 20 root 2. Now, the next one on the other side, 12 root 5. Well, 12 root 5 is actually already simplified, right? So it's done. So I'm technically just going to bring it down here, and I'm going to add it to our standing piece. And because the radicals are not the same in these 2 terms, I cannot add these 2 together. So 20 root 2 plus 12 root 5 is done. That's your answer. Let's try another multiplication. This one, I added some variables in there. So let's go ahead and treat it the same. I'm going to go ahead and start by distributing into my first term. So here, negative 2 times 3, those are my coefficients. So that's going to leave me with negative 6. Now let's look at my radicals. I have root 3x times 6. That's going to leave me with radical 18x. And that's the first piece. Now let's go ahead and distribute into the second piece here. Negative 2 times 2, those are my coefficients, leaving me with negative 4. And then root 3x times root 10x. That's going to leave me, be real careful here. The 3 times 10 gives me 30. And the x times x gives me x squared, using our laws of exponents. Now we're at this point, go ahead and draw a little line down the middle because you have to do 2 separate problems. I'll go ahead and do the first one. I always like to do this first. I like to break everything into all of its pieces. So I'm going to break this into negative 6 times root 18 times root x. And then I'm going to go ahead and simplify. So I'm going to break things down here. Negative 6 times, I can break 18 into root 9 and root 2. And I know that the square root of x is still just the square root of x. Keep simplifying everything. Keep going back as far as you can. And be sure to make sure you're putting all those operations and radicals in. All right, here we go. Negative 6 times 3 is negative 18. And I'm going to smush those radicals together because of the product rule. I can smush it together, which will give me 2x. Now that's just the left side. Let's go ahead and do the right side now. I'm going to break this into negative 4. Actually, I'm going to change that. I'm going to hold on to my operation for the very end. And I'm going to put subtraction at like that. If I've already accounted for it, I don't need to account for it in the actual problem. So watch what I mean by that. I'm just going to say 4 times root 30 times root x squared. Let's go ahead and break this down now. Now, here, obviously, 4 does not break down, but root 30 also does not break down. That is as far as root 30 will go. But I can simplify root x squared. That'll just give me x. So we can smush it all together to give us 4x root 30. And there we have it. You can see that our final answer is here at the bottom because we can't combine root 2x and we can't combine that with root 30. So we're done. That's your answer. So you can see it's just a little bit more complex with those variables, but you're still using the same procedure. Okay, now let's go ahead and look at the last operation. And I think the last operation is the most complex. So just kind of reviewing the radical expression rules that we talked about in a previous section here. A radical expression is considered simplified when all of the following are true. We already talked about number 1. The radicand has no perfect square factors other than 1. And that's what we've been talking about in the past couple sections with simplifying radicals and breaking them into their 2 factors. That's what we've been talking about. Now, the other 2 rules is what's going to be new here. Number 2 says the radicand contains no fractions. So what's underneath the radical cannot be a fraction. So I'm going to show you how to get rid of that fraction. And then the third rule is no radicals appear in the denominator. You cannot have a radical expression in the denominator of a fraction. So I'm going to teach you how to get rid of that as well. So let's look at a couple problems. So it says divide the following radical expressions. And you can see that this first example, the radicand is a fraction. Do you see that? The number underneath the radical is a fraction. Cannot have that. So we can do this. We can actually break this expression into the square root of 12 over the square root of 5. You see that? By doing this procedure right here, those are equivalent statements. It's actually called, it has a special name, it's called the quotient rule, meaning that we can break that into both of those pieces so that we satisfy number 2. Because now you can see the radicand does not have a fraction anymore. But you can see that this problem is unique because now moving to step 3, no radicals appear in the denominator, but we do have one in the denominator. So we have to do something called rationalizing the denominator. Watch how we do that. I'm going to take my radical that's in my denominator, and I'm going to multiply it by the top of the expression and the bottom of the expression, just like that. Because watch what this does. This is really cool. Look at just the denominators. The square root of 5 times the square root of 5 is going to equal just plain old 5. I'll go ahead and write how that actually works down here. The square root of 5 times the square root of 5 is equal to the square root of 25, right? And we know that the square root of 25 is 5. So the point of this is showing you anytime that you multiply two radicals that are the same number, it gives you just the number that's inside without the radical. So 5 is our new denominator. Now let's go ahead and do the numerator. The square root of 12 times the square root of 5 is equal to the square root of 60. So at this point, we've actually satisfied steps 1 and step 2 and step 3, right? But there is a problem. Well, it's not really a problem, but our numerator, square root of 60, is not simplified. So watch what I'm going to do. I'm going to go down here at the bottom, and I'm going to go ahead and simplify it using the skills that I've learned in previous sections here with simplifying expressions. So I'm going to go ahead and simplify the square root of 60. And remember, you can go ahead and use your Desmos calculator to help you do that. And I need to find two factors that are going to break this down. Okay? The square root of 60 is going to break down into the square root of 4 times the square root of 15, which of course we can simplify down into 2 root 15. Now that I've simplified the square root of 60, watch what I'm going to do. I'm actually going to change my pen color so I can show you. I'm going to take the 2 root 15 and I'm going to take it back up and I'm going to replace the root 60. And I'm going to rewrite it down here. 2 root 15 divided by 5. And there you have it. You're all finished. That is your final answer. Let's do a couple more problems here. You'll start to really kind of develop and understand the cycle at which you solve these. So now we have 2 root 5 over 3 root 8. And so we can see here that we really need to focus our attention on step 3 because we have a radical in the denominator. Cannot have that. So I'm going to multiply the numerator and denominator by the radical, not the coefficient in front, but just the radical. That's called rationalizing the denominator. Now, I personally like to start with my denominators because I like to see them kind of eliminate. So the root 8 and the root 8, guess what? They're going to turn into 8, right? So our denominator is now going to be 3 times 8. Do you see that? Now let's go ahead and, before we simplify that, let's go ahead and do the numerator. So I have 2 times that invisible 1, so just 2. And then I'm going to multiply my radicals to give me root 40. Now keep going. I have 2 root 40 over 24. Hopefully at this point you see an issue, right? We see that 2 root 40 is not simplified. So I'm going to kind of come off here to the side and I'm going to go ahead and simplify 2 root 40. So 2 times root 4 times root 10 and 2 times root 10 gives me 4 root 10. I'm going to change my pen color here so you can see what I'm going to do. I'm going to take 4 root 10 and I'm going to take it back up and I'm going to replace it, giving me 4 root 10 up top divided by 24. Now you may see a little issue here. Do you notice how my coefficients can be simplified down? 4 over 24 can actually simplify down to 1/6. So I'm going to go ahead and do that. I'm going to be left with root 10 with that imaginary 1 out front over 6. And that is my simplified expression. Let's keep doing just a couple more practice problems. I think I have, what do I have? 2 more here. And I threw some variables in there just for fun. So let's take a look at the first one. 5 over 4 times root 3m squared. Keep the same process going. I need to get rid of the radical in the denominator. So I'm going to go ahead and I'm going to multiply it by root 3m. That's going to be in my numerator and that's going to be in my denominator. That's called rationalizing the expression. All right, you can simplify the top or the bottom. It really doesn't matter. I'll go ahead and simplify the top here. The top will simplify into 5 root 3m squared. And you're probably thinking that is not simplified, which is great because we're going to simplify that in just a moment. Let's do the denominators. Now remember, these two, when they simplify, when you multiply those, they just leave you with what's inside. So 3m squared. So it's going to be 4 times 3m squared. You see that? Now I'll take it one more step. Okay, I'm going to write it down here. So I have 5 root 3m squared divided by 12m squared. All right, this is where we want to take the numerator. We want to come off to the side and we want to simplify it. So I've got 5 times root 3 times m squared. And the only thing that can simplify there is the m squared. So let's go ahead and do that. Giving me a solution of 5m root 3. All right, this is where I go ahead and I take that simplified answer and I'm going to go ahead and replace it. By replacing it, that's going to be 5m root 3 over 12m squared. Now, do you notice how the coefficients are simplified? 5 over 12. I'm not going to touch those. But do you also notice that I have an m in the numerator and an m squared in the denominator? I need to simplify those. So go ahead. I'm going to simplify them by using my laws of exponents. I'm going to be left with 5 root 3. Since I got rid of, I only have 1 in the numerator, I've got 2 in the denominator, I can cancel those out, giving me 12m in my denominator. And there you have it. You're all finished. Everything is simplified. All 3 of those steps are satisfied. Let's take a look at one more, and we'll call it a day in this lesson here. So, of course, I have a radical in the denominator, so I need to rationalize it. Start there. I'm just going to multiply by root 8n. And I'm going to go ahead and simplify everything out. 2 root, watch what I'm going to do. 3 times 8 is 24, n to the 4th, divided by 7 times 8n. I'm going to go ahead and simplify that down a little bit. I'm not going to do the numerator yet because I always like to kind of go off to the side there, right? But I am left with 56n in the denominator. All right, take that numerator, take him off to the side. There it is. And break them down. 2 times root 24 times root 4. I'm sorry, n root 4. Keep breaking them down. 24 can break into 4 and 6. And the square root of n to the 4th is just going to be n squared. Okay, so now I have 2n squared. Oh, I'm sorry, I forgot a step. Forgot to simplify it. 2 times 2 times root 6 times n squared gives me 4n squared root 6. All right. This is where I'm going to grab my other color and I'm going to take them and replace them. So we have 4n squared root 6 divided by 56n. We've got a little bit of simplifying to do here, don't we? So 4 divided by 56, that can be simplified to 1/14. So I'm going to have a 1 up top with a 14 at the bottom. N squared over n will leave me with an n up top with a root 6 in the top. We are all done. Fully simplified. Now I know that was quite a bit. We had a lot of simplifying to do, a lot of operations, but that brings us to the end of our lesson on operations with radical expressions.